Hello, my name's Jeff, and I teach accounting and finance and Excel. So here is a time value of money problem where it says, what is the size of the payments that must be deposited in the beginning of each 6 months period in an account that pays 5.6% interest compounded semi-annually? So the account will have a future value of $190,000 at the end of 16 years. Now, to work this problem, I'm going to use Excel. So that's going to be my way of doing it. And I think that Excel is one of the best things we can do for this. So here is our problem here. I've just converted it to Excel. Now, if you want to use a formula, hey, more power to you. I'm happy to show you the formula. This is an annuity due. Now, let's just briefly talk about a stream of equal payments. It's called an annuity. If the payments happen at the end of the period, that's our normal assumption, then we have an ordinary annuity. If the payments happen at the beginning of the period, that's called an annuity due. So you need to find the formula for an annuity due, find the payment formula given a future value. So this is what we have. So for Excel, I need to set up a little table here, and I'm going to show you how this works. So the periods per year is 2, and that's just going to help us understand it's 2 semi-annual periods each year. For Excel, we're going to have to say, hey, it's beginning periods. The payment happens at the beginning of the period, so that's a 1. So N is the number of periods. So it's going to be 16 years times 2. So that's going to be 32 half years, because 16 full years. The annual interest rate is 5.6%. Now, on this one, we want it to be a decimal form, so 0.056 is the annual interest rate, and we can convert this to a percentage if we want to. So I like to think of it as a 5.6%, but the periodic rate would just be 5.6 divided by the number of periods, which is 2, so divide it in half. And so in decimal form, this is 0.0280. Now it's 2.8% every 6 months, but this is the decimal format. We're going to stick with that. There's no present value. We don't have any numbers right now. Now we're trying to solve for the payment, so that's going to be our blank. But we do know our future value. Our future value is $190,000. So what we're trying to do is get to $190,000 by putting in payments at the beginning of the 6-month period. We do that at the beginning of each 6-month period for 16 years, so 32 payments. So what does it take? Well, we're going to have interest along the way, and that's going to help us. Now, if you want to use the formula, the future value is 190. The R is the periodic rate, so it's 0.028. 1 plus the R again to the nth power, which is 32 minus 1, and then you multiply this one more time, and you'll get the payment. You should get the same payment as we get here. I'm going to use Excel because Excel is built for this. So I'm going to use the FX function, and this is the payment function. I'm going to look for this. And so here's what I need. I need the rate. The rate is the 2.8%. The number of periods is 32. The present value is 0. The future value is 190,000. The payments, now watch, the payments happen at the beginning of the period, so we need to put a 1 here. I'll just point to the 1 that we have already used. And so we're done. Our answer is $3,644. The way that Excel works is it's a negative payment. You're paying $3,644 to receive $190,000. We can take that negative number out and just make it negative. Negative makes it positive. And so the answer, whether you use the formula or use Excel or use a financial calculator, the answer should be $3,644.95. Hey, thanks.